Antarctica, a land of icy plains and towering glaciers. Beneath this frozen facade lies a hidden threat. Antarctica is home to a network of volcanoes, some of which are active. These volcanoes are hidden beneath thousands of feet of ice. Their eruptions are a mystery, their power unknown. Scientists are only just beginning to understand the true extent of Antarctica's volcanic activity. The implications of these volcanoes are far-reaching. They have the potential to destabilize the entire West Antarctic ice sheet. This could lead to a catastrophic rise in sea levels, flooding coastal cities around the world. The discovery of these volcanoes is a wake-up call. Our future may depend on understanding and mitigating their impact. Most people think of volcanoes as towering mountains, spewing lava and ash. But in Antarctica, many volcanoes are hidden from view. They lie beneath the ice sheet, their presence only hinted at by subtle clues. Scientists use ice-penetrating radar to map the shape of the volcanoes beneath the ice. They also monitor seismic activity, which can indicate magma movement. When a volcano erupts beneath the ice, it can melt vast quantities of ice, creating huge lakes of meltwater. These lakes can then drain rapidly, causing catastrophic floods. The interaction between magma and ice creates a unique type of eruption. This is unlike any other volcanic activity on Earth. The sheer power of these hidden volcanoes is a stark reminder of the forces that shape our planet. As we continue to study these volcanoes, we will gain a better understanding of their potential impact. Subglacial eruptions are a fascinating and complex phenomenon. The intense heat of the magma melts the overlying ice, creating a cavern filled with meltwater. This meltwater cools the magma rapidly, forming a glassy, fragmented rock called hyaloclastite. As the pressure builds, the volcano can erupt, spewing ash and steam into the atmosphere. These eruptions can create massive depressions in the ice sheet, known as volcanic cauldrons. By studying these cauldrons, scientists can learn about the frequency and magnitude of past eruptions. The discovery of subglacial volcanoes has changed our understanding of Antarctica. It is not a static, frozen wasteland, but a dynamic environment shaped by powerful forces. The study of subglacial volcanoes has real-world implications for our understanding of climate change and sea level rise. By understanding the past behavior of these volcanoes, we can better predict their future impact. This knowledge is crucial for developing strategies to mitigate the effects of climate change. In recent years, scientists have made some alarming discoveries about Antarctica's subglacial volcanoes. One study revealed a massive volcanic heat source beneath the West Antarctic ice sheet. This heat source is thought to be responsible for melting the ice sheet from below, contributing to its instability. The study's authors used radar and seismic data to map the heat source. They found it beneath a region of the ice sheet that is already thinning rapidly. This suggests the heat source significantly impacts the ice sheet's stability. Another study found evidence of a massive volcanic eruption in Antarctica about 2,000 years ago. The eruption, beneath the West Antarctic ice sheet, is thought to have been one of the largest in the past 10,000 years. These studies highlight the potential for large-scale volcanic eruptions in Antarctica and their impact on the ice sheet. Continued research is essential to understand and mitigate the risks posed by these hidden volcanoes. The implications of volcanic activity beneath Antarctica's ice are far-reaching. One of the most significant concerns is the potential for sea level rise. The West Antarctic ice sheet contains enough ice to raise global sea levels by several meters if it were to melt completely. Even a partial collapse of the ice sheet would have devastating consequences for coastal communities worldwide. Volcanic eruptions could also disrupt global climate patterns. Large eruptions can inject massive amounts of ash and sulfur dioxide into the atmosphere. These particles can reflect sunlight back into space, leading to a cooling effect on the planet. The ash and gases released from volcanic eruptions can also disrupt air travel. The discovery of active volcanoes beneath Antarctica's ice sheet is a stark reminder of the powerful forces that shape our planet. It is a call to action to better understand these forces and develop strategies to mitigate their potential impact. While the direct impact of a single subglacial eruption might be localized, the cumulative effect of multiple eruptions over time could be significant. The release of meltwater from beneath the ice sheet could lubricate the flow of ice towards the ocean, accelerating ice loss and contributing to sea level rise. This is a slow but relentless process that could have devastating consequences for coastal communities over the coming centuries. The interaction between volcanoes and ice sheets is complex, with feedback loops that are not yet fully understood. As the ice sheet thins due to climate change, this pressure release could lead to more frequent or intense eruptions, creating a vicious cycle of ice melt and volcanic activity. By studying the history of volcanic eruptions and their impact on the ice sheet, scientists can develop models to predict how future eruptions might unfold and what their consequences might be. This information is crucial for developing strategies to adapt to a changing climate and mitigate the risks posed by a warming world. The challenges of studying volcanoes in such a remote and extreme environment are significant. However, the potential rewards in terms of scientific understanding and societal benefit are enormous. By unraveling the mysteries of Antarctica's fiery underbelly, we can gain a deeper understanding of our planet's dynamic processes and our place within its intricate web of life. The discovery of active volcanoes beneath Antarctica's ice should serve as a wake-up call to the world. It highlights the interconnectedness of Earth's systems and the potential for seemingly distant events to have global consequences. The melting of the West Antarctic ice sheet, for example, would have a devastating impact on coastal communities around the world, displacing millions of people and causing trillions of dollars in damage. The threat posed by Antarctic volcanoes is not immediate, but it is real and growing. As climate change continues to warm the planet, the likelihood of volcanic eruptions beneath the ice sheet increases. This is why it is so important to continue to study these volcanoes and to develop strategies to mitigate their potential impact. We need to continue to monitor these volcanoes and improve our understanding of their behavior. This includes monitoring seismic activity, ground deformation, and gas emissions. Developing better models to predict the impact of volcanic eruptions on the ice sheet will require collaboration between volcanologists, glaciologists, and climate scientists. The more we understand about these volcanoes and their potential impact, the better prepared we will be to deal with the consequences of an eruption. Research into Antarctica's subglacial volcanoes is crucial for several reasons. First, we need to improve our understanding of the number, location, and size of these volcanoes. This information will help us to assess the potential threat they pose and to develop mitigation strategies. Second, we need to study the history of volcanic eruptions in Antarctica. By analyzing ice cores and other geological records, we can learn about the frequency and magnitude of past eruptions. This information can help us to predict the likelihood of future eruptions. Developing better models to predict the impact of volcanic eruptions on the ice sheet will require a multidisciplinary effort involving volcanologists, glaciologists, and climate scientists. International collaboration will be essential to share data, expertise, and resources. Finally, we need to educate the public about the threat posed by Antarctic volcanoes to raise awareness and build support for the research needed to address this threat. Understanding the risks associated with Antarctic volcanoes is a complex task that requires a multifaceted approach. Continuous monitoring of seismic activity in the region is crucial. By deploying sensitive instruments across Antarctica, scientists can detect subtle tremors and variations in Earth's crust, providing valuable clues about magma movement and potential eruptions. Another important area of research is the analysis of ice cores, which act as frozen time capsules preserving traces of past volcanic eruptions. By examining the layers of ash and chemical compounds trapped within the ice, scientists can reconstruct a timeline of volcanic activity spanning thousands of years. Satellite observations play a vital role in monitoring changes in ice sheet dynamics. By measuring ice flow velocity, surface elevation, and the presence of meltwater, scientists can identify areas of instability and potential triggers for volcanic eruptions. Combining these observations with ground-based data provides a comprehensive view of the complex interplay between volcanoes and ice sheets. Understanding the risks associated with Antarctic volcanoes requires a collaborative effort from scientists across various disciplines. Raising public awareness about the potential threat of Antarctic volcanoes is crucial for garnering support for scientific research and prompting policymakers to take action. While these volcanoes may seem geographically distant, their impacts could be felt globally. By communicating the potential consequences of volcanic eruptions, such as sea level rise and climate disruption, we can engage the public in a meaningful dialogue about the importance of understanding and addressing these risks. One effective way to spread awareness is through compelling storytelling that connects the science of Antarctic volcanoes to human experiences. By highlighting the potential impacts on coastal communities, global food security, and the delicate balance of Earth's climate system, we can make the issue more relatable and urgent for people who may not have considered it before. Educational initiatives such as museum exhibits, documentaries, and interactive online platforms can also play a vital role in disseminating knowledge about Antarctic volcanoes. These platforms can showcase the latest scientific discoveries, illustrate the potential consequences of eruptions, and highlight the importance of continued research and monitoring efforts. International collaboration is essential for addressing the global threat posed by Antarctic volcanoes. The fate of Antarctica's volcanoes and their potential impact on the planet hang in the balance. The choices we make today will determine the course of events in the decades and centuries to come. If we continue on our current path of unchecked greenhouse gas emissions, we risk triggering a cascade of events that could reshape our planet. We must act now to reduce our emissions and mitigate the effects of climate change. This will require a global effort, with all nations working together to transition to a clean energy future. We also need to invest in research to better understand the risks posed by Antarctic volcanoes and to develop strategies to mitigate their impact. The future may seem uncertain, but one thing is clear: we cannot afford to ignore the warning signs. The fate of Antarctica, and indeed the entire planet, may depend on our actions in the years to come. We have the knowledge and the tools to address this challenge. What we need now is the will to act.